we're going to talk about the exciting topic of air filters. Air filtration is important to the operation of your building because A, you want to provide a cleaner, healthier environment for your occupants, but also B, it helps protect your HVAC equipment. There are many different types of filters out there though, the different MERVs, HEPA filters, etc. But of course you want to get the most cost-efficient ones that last long, work well, but don't break the bank. But did you know that most of the cost of air filtration isn't from the cost of the filter itself? 80% of the air filtration cost actually comes from electricity used by the fan to move air across that filter. How does that work, you ask? Well, no matter the type of filter, the basics are the same. Filters are made up of closely woven material to catch particles such as dust or car exhaust in the air. But if the filter can stop particles that you can barely even see, it can also slow down the airflow. This is called resistance. The resistance is small, but this means that your fan has to work just a bit harder to pull air through those filters on the left and into your building. That also means that your fan will have to use just a bit more energy to get enough airflow to that one CEO who's working in that corner office on that furthest floor. We also call this the pressure drop across the filter. Resistance from the filter causes the higher pressure or higher speed air on the left to be at a lower pressure or slower on the other side. That is that pressure drop. Just like resistance, we don't want that pressure drop to be too great across the filter. So why don't we just choose the filter with the lowest pressure drop then? Unfortunately, more efficient or better filters come with larger pressure drops. This is because these filters are able to capture more dust particles and such in the air because they're made up of more closely woven material, and that means that's more resistance for your fan. Not to mention, as the filters get older, they will accumulate more dirt, and that increases the resistance as well. This graph shows what happens over time to the resistance of a typical filter. To compensate, your fan will have to work harder and use more energy over time. So, what can we do to balance air filtration and fan energy? What we usually recommend is to move over to V-bank filters. This style of filter is different because of the wide open entrance, with about 30% more area at the inlet and 60% more area at the outlet. This creates a dynamically shaped airflow pattern, which minimizes the pressure drop across the filter. The starting and ending pressure drops for this type of filter is also similar to other high-performing filters. But the way these work is that they have a different resistance curve throughout its life cycle. In other words, the pressure drop for V-bank filters is lower for longer. They also last longer. V-bank filters last about 1.5 years, whereas typical bag filters you would have to change out maybe every 2 to 4 times a year. So on average, you would go through one V-bank filter in the time you would normally go through 4 typical bag filters. In fact, the CDC, or the Centers for Disease Control and Prevention, which is the National Public Health Institute of the US, they conducted a study comparing different filters at their government buildings, and they found that their V-bank filters actually lasted for 3 whole years. When you want to compare how V-bank filters perform to typical bag filters, it would actually be more accurate to compare them like this. 1 V-bank filter in the green and 4 typical bag filters in the purple. As you can see, the resistance of the V-bank filter is lower for most of its life and is lower than the typical filters for about 3/4 of its life. This is how that translates to fan energy. We studied this at an actual building and compared how the fan would work or how the fan worked with original filters and how they would work with V-bank filters. As you can see, the fan works much less and uses much less energy over time. So the real question, what you're all wondering, is how much could this actually save? We calculated the energy savings from switching over to V-bank filters for numerous buildings in the greater Chicago area, and we're going to go over a couple examples. Both of these are commercial office, and for the first one, about 300,000 square feet, we calculated that by switching over to V-bank, they could save about 27% in fan energy. That's over the course of a year. That translates to 70,000 kilowatt hours for the whole year and about $10,000 to $15,000 in cost savings. For building number 2, this is also commercial office, about 700,000 square feet. We calculated 53% in fan energy savings over the year 200,000 kilowatt hours and $18,000 to $23,000 in cost savings. Of course, every building is different, but in general, we're seeing pretty good savings with vaping filters. On top of those electricity savings from reducing the fan energy, since these filters last longer, you can also save by having to do fewer filter changes. That means fewer filters to buy, and also fewer maintenance hours from the building engineers that have to switch them out. There are also sustainability benefits to vaping filters. By not having to go through so many, you reduce your waste and you lower your carbon footprint. This comes from less transportation fuel, fewer trees you have to use for paperwork and packaging, and less water waste from producing those filters. So if you're interested in learning more about V-Banks, come see us. V-Bank filters can be used in a variety of situations, from VAV to constant flow air handlers. If you have humid or turbulent air, perhaps you need your filters to be lightweight, moisture resistant, et cetera, et cetera. And they also eliminate the need for a pre-filter. Speaking of pre-filters, fun fact from Greg, who also loves filters. Pre-filters are used to prolong the life of more expensive, more efficient filters down the line, usually. But you may not need them in your building, and your fans may just be working harder for no reason. So if you have questions about this or filters in general, come talk to us. We'll be happy to help. Thank you.